What did the universe look like right after the Big Bang, 13.7 billion years ago? What is it that makes everything have a weight, weigh something? Has there been life on Mars? What secrets about past climate are hidden in the Greenland ice sheet? These are some of the questions that researchers at the Niels Bohr Institute in Copenhagen are working to answer. In Scandinavia, in Northern Europe, lies one of the world's oldest kingdoms, Denmark, with 5.5 million inhabitants. The country is not much to look at on the world map, but it is big on the scientific world map. In the center of the old capital, Copenhagen, lies the legendary Niels Bohr Institute of Physics, which is part of the University of Copenhagen. The institute is a world leader in research in the many branches of physics. Here, the world is explored from the biggest phenomena in the universe, galaxies, to the smallest parts of matter, the elementary particles in the inner universe of atoms. The Niels Bohr Institute was established in 1921 at the initiative of one of our time's most important scientists, the Danish physicist Niels Bohr. In 1913, Niels Bohr developed his famous atomic model. The theory described the atom with a positively charged nucleus that contained almost all of the atom's mass, and negatively charged electrons that orbited in specific paths around the nucleus. The electrons released or absorbed energy when they moved from one orbit to another. It was an innovation that was a radical break from the classic physics of the time. In 1922, Niels Bohr received the Nobel Prize in Physics for his fundamental contributions to the understanding of the atom and for his pioneering development of quantum mechanics, which opened new perspectives for physics. Niels Bohr was not only a brilliant scientist, but also a visionary leader of the institute, which became one of the world's most important centers for physics. Here, he created an international research environment and a unique place of pilgrimage, an open world, and a tradition that continues to this day. Many of the world's leading physicists have visited the Niels Bohr Institute for shorter or longer periods. Several of them were awarded the Nobel Prize for their work. Niels Bohr's son, Ove Bohr, also received the Nobel Prize in Physics along with Ben Mottelson and James Rainwater in 1975. Behind the almost century-old walls, there is still a dynamic international research environment where the latest scientific breakthroughs are made in collaboration with leading research groups from around the world. The Institute has approximately 375 employees, including 156 PhD students, and there are approximately 700 students studying physics. Today, the research covers all the fields of physics and range from particle physics, quantum physics, and nano and solid-state physics, from geophysics and biophysics to astrophysics. Particle physicists study the smallest things imaginable, the elementary particles found inside atoms. In order to study the smallest particles, you need big apparatus. A 27-kilometer-long particle accelerator at CERN in Geneva, Switzerland. Here, researchers from the Niels Bohr Institute are working with experiments that will provide answers to the mysteries of the universe. In the particle accelerator, atomic nuclei are accelerated and collided into each other at incredibly high energies, dissolving into a primordial soup of quarks and gluons. They are on the hunt to discover what the universe was comprised of just after the Big Bang, 13.7 billion years ago, and which forces prevailed. Quantum physics deal with the properties of matter on the atomic level. Using experimental techniques to manipulate quantum states, researchers are working on large research projects like the teleportation of information in future quantum computers and the creation of an atomic clock with such accuracy that it only loses 1 second every 300 million years. It could be used to measure distances to distant galaxies in space and search for gravitational waves. Solid-state physics and nanophysics study matter on a nanometer scale, right down to the size of individual molecules. By means of X-ray and neutron scattering, researchers study the nanostructures of solid matter, thin polymer films, and nanoparticles. You measure the electric current in a transistor consisting of a single molecule, and examine a carbon nanotube at temperatures near absolute zero, a step on the road to nanoelectronics. Biophysics is a groundbreaking research field combining physics, biology, and medicine. Using this special instrument, optical tweezers, researchers can study biological systems from whole cells to individual molecules, for example, strands of DNA. Researchers can study cell membranes and gain new knowledge about the effects of antibiotics. Biophysicists have turned the traditional medical view that the function of nerves is purely electric on its head. Research has shown that nerve membranes function by sound pulses. This means that anesthetics work by stopping the sound pulses. Geophysics is the physics of the Earth below us, but also the atmosphere, oceans, and the planet's thick ice sheets. Geophysicists at the Niels Bohr Institute are world leaders in drilling ice cores through the kilometer-thick ice sheet in Greenland. The ice sheet can give us information about the Earth's climate 140,000 years ago. Knowledge of past climate can provide us with new information about the future climate. Meteorologists deal with atmospheric physics and work with data from observations using satellites and with dynamic climate models. They study the processes that are relevant for both understanding and predicting the development of day-to-day weather and have long-term significance for the global climate. Planetary physicists study Earth-like planets in our solar system and participate in NASA's missions to Mars. They use the Danish researchers' instruments to examine the magnetic properties of Martian dust and the planet's habitability for life. There is a broad range of research in the fields of astronomy and astrophysics at the Niels Bohr Institute. They research how galaxies and massive galaxy clusters form in order to study the evolution of the galaxy over billions of years. In the near universe, they study the Sun's active atmosphere, the corona, and the explosions of magnetic energy from the surface of the Sun, which give rise to solar storms and the aurora borealis here on Earth. They research how the planets were formed in our solar system. Exoplanets are also in the researchers' spotlight. Exoplanets are planets orbiting a star other than the Sun. Thousands of exoplanets have been found in our galaxy, the Milky Way. They are looking for habitable planets with the potential for life. In addition to the visible universe, planets, stars, and galaxies, it was discovered a few years ago that more than 95% of the universe is comprised of dark matter, which is not visible but contributes to gravity, and dark energy, which contributes to the expansion of the universe. It is not yet known what this is, and intense research into the mysterious dark universe is being done. Physics is the exploration of this wonderful wide world. from the smallest parts to the biggest.